Okay, we're here today. We're gonna work on your Streamflow Lab. Those that were here first period on Friday the 13th, you already have done the data. So you already run through the lab. Those that were in period 1 that weren't here Friday the 13th, I want to go over how to actually do the lab. And those that were in period 7, 8, since I didn't see you on that Friday, you didn't have a chance to do the lab. So if I'm looking at the lab, the data is already supplied to you by period 1. But I want to go over so this way you actually know what's going on. So the first thing you had to do on the lab was to find the length of the trough, the nearest 1/10 of a centimeter. Once you have that, notice there's no space to write that down, so we had put it off to the side. We're going to need that length to figure out the velocity, because velocity is the distance divided by the time. So we're going to use our trough. First thing we're going to do is we're going to use one hose. One hose is equal to your data table low. So we get the water going on. Okay, what we're going to do is first we're going to use food coloring. We're going to put a drop of food coloring at the top of the trough, and we're going to time how long it takes to get to the bottom of the trough. That's going to be your travel time. So right now I'm at a 5-degree slope. Put the food coloring in. Time how long it takes to get to the bottom of the trough. For you guys, that is your 2.2 seconds. Next, your velocity. Your velocity, remember, I'm taking the distance or the length of the trough and I am dividing it by the travel time. All right, so that's how you they ended up getting the 37.2 centimeters per second. Next, I'm taking a pinch of silt. I'm going to time how long it takes that silt to get down from the top of the trough all the way down to the bottom of the trough. For you guys, that's the 2.3 seconds. And then I'm going to do the same thing with sand. Drop the sand at the top of the trough, time how long it takes to get to the bottom of the trough. And for you guys, that's 2.4 seconds. So that's my 5 degrees low. My 5 degrees high means I have 2 hoses. So I have twice the volume. Now if I increase my volume, I need you guys thinking back to your notes. If I increase my volume, what should happen to my velocity? You're right, the velocity should increase. So I'm going to try to get the second hose that have the same volume as the first hose. Then I'm going to blend them and have them try to become one. Then I'm going to repeat everything. So here we are as 1, 5 degrees, 2 hoses, so that's my high. I'm going to time how long it takes the food coloring to get down. All right, you guys have it as 1.7 seconds. Then I'm going to do the same thing with my pinch of silt. And then my pinch of sand. All right, so we have done the 5 degrees. So we have done the 5 degrees low, that's the one hose. How long took the food coloring? Taking the length of the trough divided by the travel time gave me the velocity. This is how long it took the silt. This is how long it took the sand. 5 degrees high, that's with the 2 hoses. That's how long it took the food coloring. I took the length of the trough divided by the travel time. I got my velocity. This is how long it took the silt. This is how long it took the sand. If you notice, the next thing is asking you to put it to 10 degrees. So I would increase the slope of my stream table to 10 degrees. Start again with 1 hose. That's my low. How long it takes the food coloring. All right. How long it takes the the silt and the sand. Then I double my hose again. It's my high. Then I'm going to bring it up to 20 degrees. I'm going to repeat again. So reminder, the travel time is how long it took the food coloring. The velocity, I take the length of the trough divided by the travel time of the food coloring to get my velocity. And these are the time for the silt and the coarse sand. Low 1 hose, high 2 hoses. Now, I need you looking at the graph. The graph, you notice the x-axis, you're doing slope. I've already plotted the 5 degrees for the low and the 5 degrees for the high. I use those two different symbols. I already gave you your velocity. Remember, you're only plotting these numbers. Round them off to the nearest whole number. So what I need you to do is plot the low for the 10 degrees and the low for the 20 degrees. Take those three, the one from the 5, the 10, and the 20, and connect those. Then I need you to take the velocity for the 10 degrees high and the 20 degrees high and plot those two values and connect it with my high for the 5 degrees. I've explained it down here for you. Then I need you to answer the questions. Complete sentences. So think, if the velocity is greater, what should happen to my rate of erosion? Now, if you've been watching the stream videos that I post on Google Classroom, you should understand, the faster the water flows, the more erosion you're going to have. As far as the size goes, look at your Google Classroom. I'll be plotting how to read your graph on your reference table, page 6. Number 8, you're explaining why the stream velocity may change season to season. Think, what do we normally have in the late winter or early spring? What usually happens to that snow? It melts, right? So we have more volume normally. Walk me through, think higher temperatures, what happens to the rate of evaporation. Walk me through a couple seasons and let me know. Thank you. Good luck.